And now review for exam 3, which is covering chapter 4. For the minimum and maximum values, we need to take the derivative, find out where it's equal to 0, and find out where it's undefined. So the derivative in this case is going to be a product rule. So we've got t times the radical, take the derivative of t, which would just be 1, and then leave the radical alone, plus leave the t alone, and then take the derivative of the square root. Derivative of a square root is 1 over 2 times that square root. Oh, this is a 4. Minus t squared. And then do the chain rule. The derivative of the inside would be negative 2t. So if you set the bottom equal to 0, that would mean that 4 minus t squared is equal to 0, which means that t squared is equal to 4, and t is then equal to plus or minus 2. So negative 2 is not in this interval, but t equals 2 is an important number. So that's what makes the derivative undefined. How about when the derivative equals 0? So let's see what can cancel over here. The 2's can cancel. And then this part right here is going to be negative t squared. And then it's still divided by 4 minus t squared inside of the square root. Then what I'm going to do is multiply both sides by this square root of 4 minus t squared. The reason for doing that is to get rid of this fraction. So then distribute and distribute. On the left side, it's still going to equal 0. When you distribute this radical to that radical, the square root is going to be eliminated. It's just going to leave 4 minus t squared. When you distribute the radical to this one, they're going to cancel, and it's going to leave just minus t squared. So then we would have 4 minus 2t squared, or if you add 2t squared to both sides, 2t squared equals 4. Then divide by 2, so now t squared is equal to 2. And then take the square root, so I'm just going to put that over here. T equals plus or minus the square root of 2. That way we've got space right here for the graph. Then graph the function. So I already typed that in, x times the square root of 4 minus x squared. And then change the window to go from, well, I'm going to have it go from negative 2 to 3, just widen the window a little bit from what this is. And then graph. And so it looks approximately like this. And so it's only defined between 2 and negative 2. And then right here, that should be the positive square root of 2. And right here, where there's a minimum, that should be the negative square root of 2. Let's see how my prediction works out. Trace, take the square root of 2. So that's the maximum. So there's a maximum at 1.414, comma 2. And then this one, because it's symmetric, should be negative 1.414, comma negative 2. So let me make sure. Do the negative square root of 2. And yes, negative 1.14 and negative 2, that's the minimum. All right, we're already halfway done with this page. Next, use a line to approximate this. So first of all, the function is going to be the fourth root of x. And then the idea is you should be able to calculate this even without a calculator. So pick a number that's close to 16.2 that you would know the fourth root of. So that would be when x equals 16. And then the fourth root of 16 is 2. So we now have a point. And in order to find a line, you need two things. You need a point and you need a slope. Well, slope is going to come from the derivative. So for this problem, I could rewrite it as x to the 1/4. And then its derivative is going to be 1/4 x, and then subtract 1 from the exponent, which leaves -3/4. Since I'm personally allergic to negative exponents, then I need to rewrite this as 1/4x to the 3/4 power. And then substitute 16. So y prime is going to be 1/4 times, and then substitute 16 to the 3/4 power. And then let's see if I can do this without a calculator. So this means take the fourth root of 16, that would be 2. And then cube of 2, that would be 8. So this turns out to be an 8 times 4, so the slope is 1/32. Then, just to make sure that I did that right, 1 divided by 4, and then 16 is raised to the 3/4 power. And then convert that to a fraction. It says it's 1/32. So that is the slope. So now for our line, we've got a point and we've got a slope, so we could use the point slope formula. So y minus the y value of 2 equals the slope 1/32 times x minus 2. And now the last part is plug in the 16.2. Oh, I put the wrong value right there. Well, I'm not reshooting this video because of that. I'm just going to fix it. Use my little eraser. That's supposed to be x minus the x value of 16. So it's 1/32, and then a 16.2 minus a 16 is just a 0.2. And then last, solve for y, so it's going to be 0.2 divided by 32, and then add 2 to both sides. And of course, I could do this without a calculator, but, but since I paid for the calculator, I might as well use it. So that is 2.006. And then finally, use the calculator to find out what the actual answer is. So math, x root, take the fourth root of 16.2, and at least at 3 decimal places, it's perfectly correct. And now for Newton's method. So sometimes it will have a function like the square root of x equals another function, and you need to put them on one side and set it equal to 0. With this, they already gave us the function, and so we can go ahead and take the derivative. So for that, we need to use the product rule. So the derivative of x squared is 2x. Leave the sign alone, plus leave the x squared alone, and then the derivative of sine is cosine. And then the formula is x minus, and you put the function on top, and the derivative on the bottom. Okay, then we need a guess, and it needs to be a positive number. Well, root means where does it equal 0? And because I've taught trigonometry 114 times, I happen to know that sine of pi equals 0. So I'm pretty sure that pi is the answer. So I'm going to start with pi. No, I'm going to start with 3 and see if the formula right here can find the answer pi. So I'll start with x0 equals 3. And let's see how fast it can find the answer. So take a 3 and store that as x. And then type in this formula, x minus, and then you should put the numerator in parentheses and the denominator in parentheses. So it is x squared sine of x, that's in parentheses, divided by 2x sine x plus x squared cosine x. And then that one's in parentheses. And it says, well, Greg, 3 is a pretty good guess, but the answer is actually closer to 3.158. Then store that as x, and then put second enter, hit enter, and it says, actually, I'm thinking the answer is closer to 3.142, which is pretty close to pi. And then, let's see, are we going to get the final answer? 3.142. Good old Newton's method. So once these are the same, we're done. X equals 3.142. Find all of the minimums and maximums for this function. And because we're given an interval, you do need to check the endpoints to see if it's a minimum or a maximum. Well, to begin with, take the derivative. So this is going to be the product rule. The derivative of x is 1, and then leave the e function alone, plus leave x alone, and now take the derivative of the e function, which is the e function. Then do the chain rule. Take the derivative of sine, which is cosine. And finally, do the chain rule again, take the derivative of 2x, which is a 2. And then set it equal to 0. So all of these functions in here are continuous, so there's no place where the derivative is undefined, but there's probably places where the derivative equals 0. What I could do is factor out the e function. What it leaves is 1 plus, and then there would be 2 times x times cosine. Then, when does this one equal 0? Never. The e function never equals 0. When does this one equal 0? So since this one has an x multiplied with a trig function, then we can't just use like cosine inverse or something like that. So we need some method to solve for this. In the directions, it didn't say you need to use Newton's method to find the solution, so I'm going to use the calculator. So when does 1 plus 2x cosine of 2x equal 0? And I need to change the window to go from 0 to 2 pi. And the y values don't really matter, negative 10 to 10, because all I need to see is the x-axis. So there's one answer, two answers, 3, and 4. So to find out where it equals 0, go to second calculate. There's number 2, the 0. And then that one is at approximately 1. So you could move the cursor, or you could just say look between 0 and 1.5, and I think the answer is 1. So it's 1.037 is one of them. And then repeat this between 2 and 3, and my guess is 2.3. So 2.244. Otra vez. That one looks like it's 5 or 4. 1, 2, 3. That's looks like it's 4. So let's see, between 3 and 5, and my guess is 4. 3.99. And for the last one, so that is 4, 5. So this one is about 5.5. Between 5 and 6, 5.5, 5.452. All right, now we need to graph the original function. So that is x and then e sine of 2x. And then take a look at the graph. And it went off the screen for just a second, so I should change the window to go up a little bit higher, like to 12. So this is a maximum, there's a minimum, a maximum, a minimum. And this is neither a minimum or a maximum, but this is actually the lowest point ever, so that's a minimum. All right, now to write down all that information. So we've got minimums and maximums. Keep them separated. So the very lowest point, that was right here, and I'm pretty sure that's 0, 0. So that's one of the minimums. The next point would be 1.037. That's a maximum. Next up is 2.244. That's a minimum. 2.244, comma, 0.846. Next is 3.99 at the top of that hill. So that's a maximum, 3.99, comma, 10.76. And then the last one, 5.452. That's a minimum, 5.452 for x and 2.014 for y. So determine where the intervals where this function is concave up. So that's a shape like this, and it also means that the second derivative is positive. So to begin with, we need to find the second derivative. The first derivative for this one will be 5/3, and then subtract 1 from the exponent, so that's going to leave 2/3. For this one, multiply by 2/3, which is going to be 10/3, and then subtract 1 from the exponent will be negative 1/3. Since this is asking for only concave up, go straight to the second derivative. So multiply by 2/3, which is going to be 10/9, and then subtract 1 from the exponent, which is going to be negative 1/3. For this derivative, bring the negative 1/3 down, and it's going to become positive 10/9. And then subtract 1/3, which is going to leave an exponent of negative 4/3. Then set it equal to 0 and get rid of the negative exponents. So for this one, it's going to be a 10 on top, 9, and x to the 1/3 on the bottom. For the next one, it's going to be 10 ninths, and then put this one in the denominator as an x to the 4/3. And then notice that if x equals 0, the derivative would be undefined. So x equals 0 is already an important point. Then what I think I'm going to do is take one of these and move it to the other side. So I'll take this one, move it to the other side. It becomes negative 10 over 9 x to the 4/3 equals 10 over 9 x to the 1/3. And then you could cross multiply. So one side would have 90 x to the 4/3, and the other side would have negative 90 x to the 1/3. Next, we could divide both sides by 90, eliminating the 90s. And now this means cube root, so you could cube both sides. Now keep in mind, hopefully from pre-calculus you're taught, sometimes when you square both sides or you cube both sides, it can give you an extra answer, which actually isn't a part of the answer. So we'll definitely need to graph and make sure that this is correct. So this is going to be x to the 4th, and this is going to be just minus x. Then we're almost done with the algebra. Add the x to both sides. So it's going to say x to the 4th plus x equals 0. And then factor out an x. It leaves x cubed plus 1. Set this one equal to 0. And set this one equal to 0. And then this one means that x cubed equals negative 1. And when you take the cube root, it's going to be the cube root of negative 1 is negative 1. Now I need another paper. I'm running out of space. Okay, so we got x equals 0 and x equals negative 1 and x equals 0. So it seems that 0 and negative 1 are the important points. Now I need to take a look at the graph of the original function and see what's going on. So the original function had x is raised to the 5/3, and then minus 5, x is raised to the 2/3. And I'll just go to zoom standard. Okay, I know that it's working on it because I can see the little spinny circle, but where is it? Oh, calculator's a little bit sleepy today. So we got 0 is an important point. The derivative does not exist there. That's a cusp. And then trace and negative 1. Oh, interesting. So remember, we're not looking for minimums and maximums. We're looking for concave up and concave down. The right side, I can tell that that is concave up. The left side, I cannot tell if that's concave up or concave down because to me it looks like a straight line. So now what we need to do is take a look at the number line. So here's 0 and here's negative 1. And then we need to pick a point like negative 1/2 and then test that point in the second derivative. So this was the second derivative. All I had done is get rid of the negative exponents. So now take a negative 1/2 and plug it in there. So if you have 10 divided by, and then 9, and take a negative 0.5 or negative 1/2, and it's raised to the 1/3 power, plus, now do this part, 10 divided by 9, and then you have a negative 1/2 raised to the 4/3 power. Then, is the answer positive or negative? It's positive. So that part is concave up. Then pick a point over here. So don't just automatically assume that it alternates positive, negative, or something like that, because these things can do whatever they want. So I need to pick a point over here like -2 and substitute that into the second derivative. So what I'm going to do is just get this one back, and I need to put in a -2 and then a -2. And then this part is negative. And when I looked at the graph, the right side looked like it was concave up, but I want to make sure, so I'll put like a 1. So back up and delete the negative, put a +1, delete the negative, and put a +1. That's a positive number. Okay, so finally it said, where's it concave up? So concave up is this middle part, so between -1 and 0, also from 0 to infinity, but do not include the 0. So it's with round parentheses and round parentheses, that's where it's concave up. So this one is asking for the antiderivative. You're given the derivative, what was the original function? So another way to look at it is, find the antiderivative of cosine of x minus, and then for this one, I'm going to rewrite it getting rid of the negative exponent. That means it's 1 over. And then 1/2 means square root. And by doing that, we're almost done. Because the antiderivative of cosine is sine of x. And then this comes from the derivative of sine inverse. So minus sine inverse of x. And then put a plus c, wrap it up, and send it off. Then for number 7, this one is a little more challenging because this is saying find the antiderivative of tangent x. And then you scroll through your memory cells and go, the derivative of tangent is secant squared. No, that's not right. The derivative of secant is secant times tangent. No, that's not right. I don't know anything where the derivative is tangent. So that means use a trig identity. Tangent is equal to sine over cosine. And then use u substitution. So let u equal, in this case, it's going to be the bottom, cosine x. The derivative of that is negative sine x dx. And this u substitution is telling me you have to have sine x times dx in the problem. Just so happens, we've got sine x times dx. But we don't need this negative, so move the negative to the other side. And then it's all ready for the u substitution. So this one is going to be the negative. I'll just factor that out to the front. The top part is sine of x dx, so it gets replaced with the negative du. And the bottom part, that's just u. And since this is just like 1 over u, the answer is negative the natural log of u. And then replace u with cosine. So the final answer is the antiderivative for tangent is negative natural log cosine of x plus c. Now there may be another time when you do this problem and you look in the back of the book or you look wherever you get your answers and it says that the answer is this. And you go, what? I did not get a secant. Well, what happened is they take this answer, and there's a rule for logarithms that says this can be used as an exponent up here. And once you do that, that means invert cosine, and 1 over cosine is secant. So both of these answers are acceptable. And then on to number 8. Where is it increasing? So take the first derivative and see where it's positive. So the first derivative will be, for the square root function, it's going to be 1 over 2 times the square root function. Whoops, this one's minus. Then do the chain rule. The derivative of the inside is a -1. The derivative of this one is going to be 1 over 2 times the square root. And then derivative of the inside will be a 1. So then set it equal to 0. Next, I'm going to take this one, which is negative, move it to the other side so it's positive. The main reason I'm doing that is because then it's going to say a fraction equals a fraction, and then you can cross multiply. So this one got moved to the left, this one is still there, and now cross multiply. So then it's going to say 2 times the square root of 1 plus x equals 2 times the square root of 1 minus x. You know what we're going to do next? You're right, square both sides. Oh, actually, before squaring, I could have divided by 2 and have the 2's cancel. That'll make it a little bit simpler. So divide by 2 to get rid of the 2's, then square, which is going to get rid of the radicals, and then it says 1 plus x equals 1 minus x. Then you can subtract 1 from both sides. And what number is it that equals itself even if there's a negative in front? Well, you could add x to both sides and then divide by 2, so x equals 0. Now let's see what's going on with the graph. So y equals the square root of 1 minus x plus the square root of 1 plus x, zoom standard. Whoa, that's a very short function. So because of these square roots, it's only defined between -1 and 1. Now if I put a 1 in there, yes, that does exist. If I put a -1, yes, that does exist. Let me zoom in a little bit. Zoom in right around the middle of it. So this, when x equals 0, that's the maximum. Trace, plug in 0. So for increasing, that's actually the left side. So for increasing, that goes from -1 to 0. And then the right side would be decreasing, but nobody asked about decreasing. So just increasing. Cha-ching! It's like free money. Then for the mean value theorem, which says that the derivative at some point c will equal the slope of the secant line, f of b minus f of a over b minus a. And the number c has to be between the a and the b. So this is the a and the b, so we need to substitute those in. So it's going to be, this is going to be the pi, so this is a and b. So substitute pi first of all. So 2 times pi plus cosine pi minus, then substitute the 0, 2 times 0 plus cosine of 0. And then it's all divided by pi minus 0. And then on this side, you put the derivative. So the derivative would be 2 minus cosine, minus sine. So 2 minus sine, and in the theorem it's called c. Then we need to solve for c. So how much is on the right side? Well, that's just 2 pi. Cosine of pi is -1. Cosine of 0 is 1, but that makes it negative. So this is a -1, and this is another -1. So it's 2 pi minus 2 over pi, and then 2 minus sine of c equals that. Then we need to solve for c, so eventually we need to do sine inverse. First, get rid of the 2. So subtract 2 from both sides. So subtract 2. And then multiply both sides by -1. So this fraction is going to get multiplied by -1. And this has to be multiplied by -1. And then take sine inverse. So the calculator's in radians, that's good. And then do sine inverse. And I'm just going to write this one first. 2 minus the fraction 2 pi minus 2 gets divided by pi, and c is equal to a 0.690. 0.690 is between these two values, so that one's done. And then to number 10, the last one, which is limits. So if you were to plug in a 0, sine of 0 is 0, e to 0 is 1, so the top is 1 minus 1. The bottom, sine of 0 is 0. That means that we could use L'Hopital's rule. So it's still going to say the limit as x goes to 0. On the top, take the derivative of the e function, which is the e function. And then the chain rule, multiply by a 2. On the bottom, the derivative of sine is cosine. And then that's good news, because when you take cosine of 0, that's equal to 1. And so this becomes just cosine of 0 is 1. This is e to the 0, then times the 2. So this is a 1 times 2, so the answer is 2. And then for this last one, so the natural log of infinity is infinity. If you square infinity, it's still infinity. So the top is infinity, and the bottom is infinity. So we could use good old L'Hopital's rule. So the derivative on the top, you need to take the 2 and bring it down and multiply, and then subtract 1 from the exponent. That takes care of the derivative of that part. Now the chain rule. Take the derivative of the natural log of x, that's 1 over x. And then on the bottom, the derivative of x is 1. So what's left is, if x is going to infinity, natural log of infinity is infinity. And then this means divide by infinity, which means it's infinity over infinity. Guess which rule we get to use next? Yep, L'Hopital's rule. So basically we have a 2x on top and take its derivative. So the 2 just sits there. The derivative of natural log is 1 over x. And then on the bottom there's just an x. So take the derivative of just that x, it looks like this. And finally we're done, because if x is going to infinity, 1 divided by infinity goes to 0, and 2 times 0 is 0.